Hello everybody, this is the third of 3 videos from Chapter 4, Section 3, and the focus of this particular video is calculating average atomic mass. This video lecture addresses objectives number 10 and 11. Number 10 says explain the difference between the terms mass number and atomic mass. Number 11 says calculate the average atomic mass of an element using relative percent abundance data. You see 3 diagrams here of isotopes of neon. You saw this on the second video lecture. And here we have neon 20, neon 21, neon 22. They are all neon because they all have 10 protons, but they are isotopes because they have different number of neutrons. So that's sort of a rewriting the definition.
Anthony Rosemark, please see Mrs. Bush in room 213.
Anthony Rosemark, go see Mrs. Bush. Isotopes, the definition. These are atoms with the same number of protons but a different number of neutrons. If you were to find the average mass of neon, if you had equal amounts of all 3, well, the mass of one of these is 20, another one's 21 and 22. If you were to find the average of those 3, 20 plus 21 plus 22, well, that would give you 63. To find the average, dividing it by 3 would give you 21. But in nature, there are not equal amounts of all 3 isotopes of neon. And there is data that exists that tells you, that gives us the percent abundance of each one of these isotopes. Well, the percent abundance of neon 20 is 90.9% of all the neon that exists is neon 20. Only 0.3% of all the neon that exists is neon 21, so very, very little. And 8.8% of all the neon that exists is neon 22. So what we have to do this is what's called a weighted average. To do a weighted average, we have to first convert the percent abundance back into its decimal form. All right, so taking the percent abundance and dividing it by 100, that will give you what we call relative abundance. And relative abundance is just the decimal form of the percentage. So what we're going to do is for each of these 3 percentages here, we're going to convert them back into their decimal form by dividing by 100, and we're going to multiply them by the mass of each one of those isotopes. So for example, 90.9 becomes 0.909. We're going to multiply that number by a mass number of 20. When we do that in our calculators, we get 18.18. For the second isotope, we're going to take the percentage of 0.3, dividing that by 100 gives us 0.003, and we're going to multiply that by 21. Calculators tell us that the answer to that particular math problem is 0.063. The third isotope has a percent abundance of 8.8. Converting that to relative abundance becomes 0.088. We're going to multiply that by the mass number of 22. And in our calculators we get 1.936. We're going to add all 3 of those up. 20.179, and we are going to now round that to the fewest digits after the decimal, which would be 20.18. The unit on that is AMUs. Okay, that number is what we call atomic mass. Notice it is not a whole number, it is a decimal number, and it represents the weighted average of all the neon isotopes that exist. Now, if you were to take a look at neon on the periodic table, the mass that is listed on the periodic table for neon is listed as 20.1797. So that number that is on the periodic table, the decimal number that is on the periodic table, is the weighted average of all the isotopes of neon that exist on the planet. And so that's what we approximated in doing this calculation. So let's write that down. The atomic mass definition, it is the weighted average of the mass numbers of all the isotopes of an element. The atomic mass will not be a whole number. In most every case, it ends up being a decimal, and it's an average. Okay, so it's okay that it's a decimal. What is the difference between an atomic mass and a mass number? We just said the atomic mass is a weighted average but the mass number is the mass of a single atom. So that's the difference. The mass number represents an individual atom. The atomic mass represents the weighted average of all the atoms of that particular element, and those atoms don't all have the same mass. Which of these, the mass number or the atomic mass, will you find on the periodic table? You will find the atomic mass on the periodic table. Mass number is not on the periodic table because mass number is just representative of a single element, single atom. It is not representative of the average of all those isotopes. All right, if you take a look at the backside, you'll find atomic mass number 3. Well, it's not labeled that way on my particular diagram, but I believe that's what it says on your paper. And I am going to ask that you round your answers to the nearest tenth. Okay, I'll do the first example with you, and then the 3 examples you can try on your own. Naturally occurring chlorine is 75.0% chlorine 35 and 25.0% chlorine 37. Calculate the atomic mass of the element chlorine. So remember, take your percentage and convert it to a decimal. So 0.750. You're going to multiply that by the mass number of that particular isotope, which is 35. And you're going to do that in your calculator to discover 26.25. The second isotope has an abundance of 0.250 with a mass of 37. And you will get an answer there of 9.25. Add them up, and you get 35.50, which rounds to 35.5 AMU. Double check on the periodic table to find that chlorine has an atomic mass listed as 35.453 atomic mass units. So why doesn't our number here match it perfectly? Well, do you suppose that the percent abundance of chlorine 35 is really exactly 75%? No, it's close, but it's not exactly 75%. So that slight variation is going to give us a slightly different variation here in our final average atomic mass. Okay, see what you can do with the rest of the problems on this worksheet.